Now the third question. The continuous function f is defined on the closed interval from -6 to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. Part A. If the integral of f of x from -6 to 5 is equal to 7, find the value of integral of f of x from -6 to -2 and show the work that leads to your answer. Part A. Allah. Okay. Now part A. From -6 to 5 f of x dx. This will be equal to we can change the boundaries from -6 to -2 f of x dx plus, look at here, we can find the areas of the triangles from -2 to 0 f of x dx plus from 0 to 2 f of x dx and finally from 2 to 5 f of x dx. And that part is given as here 7. And we want to look for the value of this integral from -6 to -2 f of x dx. Look at here from -2 to 0. From -2 to 0, the area of integral is 1 over 2. Area of integral is 1 over 2, but this is above x-axis and that part is below x-axis. Above x-axis must be shown as positive and below x-axis must be shown as negative 1 over 2. 0 to 2, these parts again will delete each other and we have to check the area of this trapezoid. That is 1 plus 3 times the height divided by 2, area of trapezoid, plus 2 to 5. From that square, we have to subtract the area of the quarter circle. So we can find the area of that part. And this is area of the square is 9 and area of the quarter circle is 9 pi divided by 4, of course. And after the evaluations, the answer will be, let me check my notes, 9 pi divided by 4 minus 4. This is the answer for part A. Now part B. Evaluate the integral 2 times f derivative of x plus 4 from 3 to 5. Let me write from 3 to 5 to f derivative of x plus 4 dx. This will be equal to, of course, integral of f derivative of x is equal to, again, f of x plus 4x from 3 to 5. And this will be, first substitute x is equal to 5. 2f of 5 plus 20 minus, now substitute 3. 2f of 3 plus 12. And remember here, it's given that point 3, 3 root 5 is on the graph of f, meaning you know that f brings the x coordinate to y coordinate. F of 3 is equal to 3 root 5. And f of 5 is, also we know that, look at that part, we know that f of 5 is also 3. If f passes through that point, f must bring x coordinate to y coordinate. And at the end, if we substitute these values, I mean f of 3 and f of 5. We will find the answer as, let me check my notes, 2 plus 2 root 5. After simplifications, we will find the answer as 2 plus 2 root 5. Now part C. The function g is given by g of x is equal to, from negative to x, f of t dt. Find the absolute max value of g on the interval negative 2 to 5. Justify your answer. Now, to find the absolute max value, of course, we have to deal with the derivative function. Also, we have to check the start point and the end point. We have to check the boundary points. Let's start. Let's first write g of x is equal to from negative 2 to x f of d dt. And to find absolute max point, of course, I'm taking derivative of this function and then equalize this derivative to 0 to find absolute max point. We are taking derivative of the given function and equalize this derivative to 0. And after that, of course, derivative and the integral will be with each other. That part will be equal to f of x. I'm repeating, integral and the derivative must delete each other. That part must equal to f of x equal to 0. And the root of f of x are negative 1, 1 over 2, and 5. Now we found the roots of derivative. So let's set our table, negative 1, 1 over 2, and 5. Between this interval 1 over 2 and 5, look at here, 1 over 2 and 5, this takes positive values. Negative 1 to 1 over 2, negative values, and when x values are less than negative 1, our function is above the x-axis, so it takes positive values. Increasing, decreasing, increasing. Since we are looking for the max value, this is relative max, first of all. Now, let's look at f of negative 1 and f of, not f of negative 1. This is related to derivative function, and this is about this increasing and decreasing intervals are for g of x. So we have to look at not f of negative 1, g of negative 1. This is the x coordinate of the relative max point. So g of negative 1 will lead us to, look at here, I have to substitute x is equal to negative 1 from negative 2 to negative 1, f of t dt, and this is equal to, from negative 2 to negative 1, look at the area here, look at the green area here, this is above the x-axis, so the integral and the area are equal to each other. This is 1 over 2. But also we have to check the, boundary points. So we have to look at here, our function is defined between negative 2 and 5. So we have to check g of negative 2 and g of 5 also. G of negative 2 is from negative 2 to negative 2. Of course, it's equal to 0. And g of 5 is G of 5 is from negative 2 to 5. From negative to 5. The area here, the area between the x-axis, that is 11 minus 9 pi divided by 4. I'm going to repeat that part. G of 5 is substitute x equal to 5 from negative 2 to 5 of the integral from negative 2 to 5. Area here 1 over 2, negative 1 over 2. These parts release each other, area of trapezoid and the blue area. And therefore G of 5 is equal to, also let me write here, this is equal to from negative 2 to 5 f of t dt. This is equal to 11 minus 9 pi over 4. And this is a greater value when we compare these two. G of 5 is greater than G of negative 1. When we compare these two, G of 5 is greater than G of negative 1. Therefore, absolute max value is 11 minus 9 pi divided by 4. And this is the answer for part C. And the final part D. Find the limit of the function 10 to the power x minus 3 f derivative of x divided by f of x minus r tangent x. Let's substitute x is equal to 1. 10 minus 3 times f derivative of 1. F derivative of 1 is equal to 2. Look at here. Derivative of our function is, look at the gradient. This is equal to 2. F of 1 is obvious that 1. F of 1 is equal to 1. R tangent 1. R tangent 1 is, you know, that equal to pi over 4. So the answer for part D is 10 minus 6. This is 4. 1 minus pi over 4. This is 4 minus pi over 4. And the answer is then at the end 16 divided by 4 minus pi. And this is the answer for part D. And I want to repeat that part. F derivative of 1. Look at here. Derivative of our function is, this is a line segment. You see that derivative of 1 is equal to, look at that triangle. Rise is 2 units and rise in x coordinate is 1 unit. Rise in y coordinate is 2 units. 2 divided by 1, this is equal to 2. Therefore, our derivative at 1 must equal to 2. And the answer for part D is 16 divided by 4 minus pi. And that's the end of third question. See you in the next video.